Hello everyone, this is Amit Arya working in ECB College Bikaner. Today I will discuss about push down automata. It is a way to represent context free grammar in a similar way as finite automata is represented by the regular grammar. You can see here are four types of grammar. Regular grammar is represented by finite state machine. In a similar way, context-free language or context-free language is represented by either context-free grammar or by push-down automata. If any push-down automata accept a language, then that language is called context-free language. This is the same case. If any deterministic finite automata accept a language, then that language is called regular language. So we will see further. Here you can see here, if this is context free language, this context free language is either represented in the form of context free grammar or accepted by push down automata. And the language is context free language. There are two types of push-down automata. One is deterministic push-down automata, other is non-deterministic push-down automata. And the power of deterministic push-down automata is less than non-deterministic push-down automata. That is, not all the non-deterministic push-down automata are not represented by the deterministic push-down automata. So all the grammars are represented, context-free grammar are represented by non-deterministic push-down automata, but some grammars, context-free grammar, are represented by deterministic finite push-down automata. That is the thing. We will see what are the components of push-down automata. Before going into mathematical form, a push-down automata has three components. One is input tape, other is finite control unit. This is the same thing as in the determinist PSA, finite state machine, finite state control unit, and in addition to that, it has one stack where you can push the symbol and pop the symbol. This is the additional part. So we can say it has three components. One is input, other is finite control unit, and third one is stack. So we can say push-down automata is FSM, finite state machine, plus a stack, and it is more powerful than finite state machine. Why this stack is added to the finite state machine? This is simply because finite state machine has limited memory, but push-down automata has more memory. By adding this stack, it get more capability to remember the things. Now the question arises, why we use stack and not any other data structure? Why we use stack? This is simply because insertion and deletion are simple in the case of stack. That is always on the top. And another thing is overflow and underflow condition. Here we consider in a stack as of the size infinite, so overflow condition just is not checked, and on to check the underflow condition we put one element here which is called Z0 element. If we see Z0 element in the stack, we know there are no element in the stack and the stack is empty. So special into stack which is known as Z0. Now we will move further. What is stack? Stack is LIFO and has two operations, push and pop. So push down automata has 7 components. Q, a finite set of states. This finite control unit has finite set of states. Sigma, a finite set of input symbols on the input tape, and tau, a finite stack symbols. So whatever the symbols that we can put on this stack are comes under this category. It may be the input tape symbol or any other symbol. Also Z0 is also one of the symbols. So all the symbols comes under tau. Next is transition function. We will see it later. Q0 is the starting state. This starting state of finite control unit, and Z0, as I have told you, if we see Z0 here, we know that the stack is empty. So to check whether the stack is empty or not, we use simple strategy. We just insert the Z0 symbol, and when we see Z0 symbol here onto the, we know it's empty. And F is the final states of in the final control unit. Also some other conditions are also there, but F is final states. So to see the transition function, we will move to the transition function. Transition function here is as in the case of regular language, deterministic finite automata, Q into sigma, set of final state into sigma, alphabet, which also include empty string, because in the input tape, as we see, we when it read empty string, it will simply stop. Sigma into tau. Tau is the topmost symbol onto stack, which will produce a state in the final control unit, and tau star. Tau star means a set of the state of the stack get changed, either pop operation or push operation or skip operation are performed in this case. This is about the deterministic push down automata. In the non-deterministic push down automata, everything is remain same, but this output is 2 raised to the q into tau star. This will be covered later on. So we can say, if transition function has triple QAX, where Q is in a state Q, A is either an input symbol in sigma or epsilon, X is a stack symbol that is a member of tau, then output is P gamma, where P is new state and gamma is a string of the stack symbol that replaces X at the top of the stack. For example, if gamma is epsilon, then stack is pop, that is symbol X is simply pop. If X gamma is equal to X, then the stack remain unchanged. If gamma is equal to YZ, then X is replaced by Z and Y is pushed onto the stack. This is about the transition function. I think that the transition function will be clear to you. So this is these seven tuples, and this structure, this components of the push down automata makes it done. Okay, thank you very much. This is the definition of push down.